Eye color is far more than a cosmetic trait. It's a biological record of how your ancestors survived and spread across the globe. While roughly 70% of the world's population has brown eyes, the remaining 30% carry genetic variations that reveal a fascinating tale of human migration and adaptation. Here's what your eye color is actually telling you. Brown eyes. Brown eyes are nature's ultimate defense system. Their deep color comes from melanin, a pigment capable of absorbing up to 90% of incoming light. Scientists at the University of Copenhagen have established that melanin acts essentially as a built-in sunscreen within the iris itself. For early humans enduring the harsh UV radiation of the African savanna, this wasn't about appearance, it was about staying alive. Melanin intercepts damaging ultraviolet rays before they can harm the DNA inside your eye cells. Beyond protection, brown eyes also outperform lighter eyes in bright conditions. Because melanin absorbs rather than scatters light, people with brown eyes experience significantly less glare and see more clearly under intense sunlight, which is precisely why this eye color dominates in populations near the equator. They look deep and consistent in most light, but under candlelight or low sun, you might catch golden or amber glints dancing across the iris. That's not your eye color changing, that's physics showing you its internal structure. Blue eyes. Every blue-eyed person alive today shares a single common ancestor who lived somewhere between 6,000 and 10,000 years ago. Geneticists trace this back to one specific mutation in the HERC2 gene that essentially disabled brown pigment production in the iris. Before that moment, every human on Earth had brown eyes. And technically, blue eyes still don't contain any blue pigment. What actually happens is that with almost no melanin present, shorter blue wavelengths of light scatter outward when they enter the eye, the exact same optical phenomenon that makes the sky look blue. This means blue eyes can appear anywhere from ice pale to soft gray depending on the light around them. The mutation is believed to have emerged during the Neolithic period, as people moved from the Black Sea region northward into Europe. What puzzles scientists is the speed of its spread. Within just a few thousand years, blue eyes went from non-existent to appearing in 70 to 95% of people in Northern Europe. Some researchers argue this gave a genuine visual advantage in low-light northern winters, where more photons reaching the retina could sharpen dim-light vision. Others point to social selection. Blue eyes were so unusual that people found them attractive, driving their rapid proliferation. Ancient DNA has also revealed something surprising. Early Europeans carried blue eyes alongside dark, African-type skin tones, proving that eye depigmentation happened well before skin lightened. This overturned the long-held assumption that the two traits evolved together. Gray eyes. Fewer than 3% of people worldwide have gray eyes, making them genuinely exceptional. They hold even less melanin than blue eyes, which produces a broad, diffuse scattering of light across multiple wavelengths rather than just blue ones, giving them that cool, steel-toned look that can shift between silver, slate, and faint green. Researchers think gray eyes may represent an extreme evolutionary response to low-light environments in places like Northern Europe, where cloudy skies and limited sun were a daily reality. The wide wavelength dispersion makes them tonally stable but emotionally harder to interpret. There's simply less color movement to observe, which might explain their cultural association with composure, wisdom, or inscrutability. That same melanin deficit, however, leaves gray-eyed people as vulnerable to UV damage as those with blue eyes, making sun protection especially important for them. Green eyes. Green eyes are found in just 2% of the global population, the rarest among commonly recognized eye colors. Their scarcity comes down to genetics. Green eyes require a highly specific combination of at least 16 genes in precise balance. Too much melanin tips them toward brown. Too little and they become blue. Green sits in a narrow middle zone where moderate melanin combines with a yellow pigment called Lipochrome to produce that characteristic hue. What sets green eyes apart further is their instability. Studies show they're particularly reactive to environmental conditions, appearing mossy in shade, gold-green in bright sun, and sometimes drifting toward hazel or blue-gray depending on surrounding colors or clothing. This shifting quality has long captured human imagination. In medieval Europe, green eyes were connected to witchcraft. In ancient Greece, they were thought to signal something supernatural. Even now, they're commonly linked to creativity and intuition. Evolutionarily, their moderate melanin may have offered a useful balance, enough UV protection for temperate climates, while preserving decent light sensitivity in forested or mountainous terrain. Populations of Celtic and Germanic heritage show the highest concentration, with parts of Ireland and Scotland reaching up to 86% prevalence. Hazel eyes. If any eye color deserves to be called a chameleon, it's hazel. Unlike other colors that stay relatively fixed, hazel eyes genuinely shift their appearance depending on light, surroundings, and even what you're wearing. This isn't a trick of perception. It's a real optical effect produced by intermediate melanin levels combined with traces of lipochrome, both of which interact with light differently as conditions change. One moment, hazel eyes red as green, then golden, then distinctly brown. That versatility mirrors their evolutionary logic. Sitting in the middle of the melanin range, they're well suited for varied environments with changing light levels and seasons. They provide reasonable UV shielding without sacrificing too much light sensitivity. Around 5% of the world's population has hazel eyes, concentrated most heavily in European and Middle Eastern ancestry groups. Genetically, hazel is a blend rather than a single defined trait, which explains why no two hazel-eyed people look quite the same. One person's iris might be predominantly green with brown flecks, another's predominantly brown with a green outer ring. That unpredictability is part of what has made hazel eyes seem so expressive and hard to define throughout history. Amber eyes. Amber eyes are frequently confused with light brown or hazel, but they're a distinct category, present in under 5% of people. What defines them is a high concentration of lipochrome with minimal melanin, producing a solid, warm golden or copper tone that remains consistent regardless of lighting. Unlike hazel, which morphs, amber stays fixed, richly golden in any condition. Interestingly, this coloration also appears in many predatory animals, including wolves, owls, and eagles. And researchers suggest that humans may instinctively read amber eyes as alert and commanding, a subtle social signal that could carry real-world advantages. From an evolutionary standpoint, amber eyes were probably shaped less by environmental light pressures and more by mate selection. Their visual intensity made them attractive enough to persist and spread. They appear most often in people of Southern European, Asian, or South American background, but can emerge anywhere given the right genetic setup. Black eyes. Truly black eyes don't actually exist. What looks jet black is, in reality, an extraordinarily dense concentration of dark brown melanin, so packed together that the iris appears to have no color variation at all. This makes them the most efficient light absorbers of any eye color, offering unmatched protection against UV radiation and glare. In regions near the equator where sunlight is constant and intense, this is a clear biological advantage. Research shows that darker eyes filter harsh light more effectively and remain visually stable across all environments. Where lighter eyes scatter or reflect, dark ones simply absorb, minimizing eye strain and potentially reducing the risk of UV-related eye conditions over a lifetime. Black eyes are most common in populations from sub-Saharan Africa, South Asia, and Southeast Asia. Culturally, they've often been associated with depth and strength, partly because the dense melanin conceals pupil dilation, making emotional states harder to read and lending their bearers an air of mystery. Heterochromia. Heterochromia occurs when a person has two differently colored eyes, or visible color variation within a single iris. It affects fewer than 1% of people, placing it among the rarest eye-related traits of all. Normally, melanin distributes evenly across both irises as they develop. Heterochromia results from a disruption to that process, caused by minor genetic mutations, mosaicism, or developmental irregularities that affect pigment distribution locally. Across many cultures and throughout history, two-tone dyes have been interpreted as marks of duality, mystical ability, or divine connection, perhaps because they violate the facial symmetry we're wired to expect. Your eye color is a biological timestamp. It encodes the journeys your ancestors made, the environments they endured, and the genetic events that shaped who they became. From melanin-rich brown eyes forged on sun-scorched plains to the blue-eyed mutation that swept through Ice Age Europe, every color is a chapter in the longer story of human survival. The next time you catch your own reflection, consider this. You're not just looking at a color. You're looking at thousands of years of evolution and the remarkable chain of events that made you possible.